Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at one of the major families of elements, and this is going to form the group 3 elements in the periodic table. Now, in this particular case, I'm going to look at this as a division of the transition elements. Now, I mentioned that basically we can categorize elements in terms of there are specific last electrons that are added to the those already present in the preceding element. And of course, I mentioned that whenever we're going to do this specific procedure, the last electron that is, of course, going to occupy the valence shell of this particular elements are going to make a set of or a group of elements we refer to as the main group element. And in this particular case, I had done a list of these specific elements and given them in categories of various block of elements which are basically listed as the S, P, D, and F block elements, which are given in terms of this specific illustration. Perhaps if we can do just a rough illustration of this particular representation. So I'd say that these first ones are going to form a set of S elements, and the rest are going to be having these 2s, 3s, 4s, 5s, 6s, and 7s. And these middle ones are going to constitute the D block elements, which are going to be given as such. And then we're going to have this last one given in terms of the P block, 2p, 3p, 4p, and 5p given as such. And of course, we're going to have the 6p illustrated as such. Now, this is going to constitute a range of elements which have been grouped according to the, of course, the position of the last electron, which has been added to the preceding, of course, electrons, which has been added to those of the preceding elements. And in this case, of course, as I mentioned, we are going to have a division of the periodic table being represented as the S and P block elements. And these are going to form what we call the main group elements. And as we can see from this one, of course, these are going to constitute this first one given as such, and the last one given as such. And these are going to constitute the main group elements given as such, the main group elements, which are the S and P block elements. Now, if we may consider this one, of course, I've given helium being represented as such. We're going to assume that it's going to be occupying such a kind of a position of the S block elements given as such. Now, in this case, I'm going to look at this particular middle section, and this is going to constitute what we refer to as the transition elements, which basically we're going to give us the D block elements. And in a sense, as we can see, these are going to constitute the inner and outer transition elements. And in a sense, if we can look at this, of course, this is also going to be the F elements are going to be an integral part of this specific section, but we have assumed it and given it an overall, of course, a group of the D block elements. And in a sense, I'm going to, of course, make an assumption that this is going to be taken as an integral part of this specific division of a transition element. Now, this is simply because these are going to be the inner transition elements, while this one are going to be constituting the outer transition element. Therefore, I'm going to look at the specific characteristics of this particular section of the transition elements, which are going to constitute basically the group 3 to 12 given as such. So I've included that one intentionally so that we can look at the general characteristics of this specific set of elements. Now, these are going to form a group 3 to 12, as I have said. And basically, if we try to look at the outer transition elements, which are going to constitute elements excluding the F block, we're going to see that they are going to have general properties whereby they are going to be stable and reactive. And also, we are going to see that one of the characteristics is that they are going to be harder compared to the group 1 and 2 elements which we had listed. And then we're going to see that they're going to contain a relatively higher boiling points and melting points as compared to the group 1 and 2, as we said. And then we're going to see that also their density is going to be higher as compared to group 1 and 2, as we have said. So these are some of the variables which we're going to consider whenever we're going to do a comparison between the group 1, 2, or the trend of the characteristics of elements across a specific period, or down a specific group from group 1 to, of course, as we are going to see, group 18. And in this particular case also, we are going to see that another characteristic of these particular elements is that they're going to form, unlike the group 1 elements, which we had said that are going to form, of course, ions with a charge of positive 1, and group 2, which are going to form a charge of positive 2. The group 3 to 12 elements are going to form a range of ions which are going to be having various positive charges. And of course, this is going to be exploited as one of the characteristics of being used in various applications due to their higher strength, which I've mentioned. And of course, application in various areas of electrical works, and of course, in jewelry. Now, in this particular case, we're going to also have a periodic table of elements, which I'm going to, of course, identify the position of these specific groups. And of course, as we're going to see, we're going to look at the individual reactions of the various groups ranging from group 3 to 12, and some of the application areas, as we're going to look, of course, in our subsequent videos. Now, in this case, I'll have an illustration of the periodic table where we're going to identify these specific groups and try to see which are some of the specific positions they're going to occupy in the periodic table. Now, above this is going to show us a specific section of the periodic table which is going to constitute these transition elements. Now, as I had said, of course, this is going to be a combination of the inner and outer transition elements which have been given as such. And of course, I'm going to give this one this specific notation. And down here in my lower section, I'm going to have this block of elements which are going to be basically a combination of lanthanides and actinides series, which are going to form what we refer to as the inner transition elements, which are going to give us this specific set. Now, in this case, I mentioned that these are going to form a range of D block elements, and the inner transition elements are going to form what we refer to as the F block elements, respectively. Now, the combination of the two are going to form a family of groups ranging from 3 to 12. And as we said, of course, these are going to be the transition metals, which are going to be having the specific characteristics or the general characteristics which we had defined in our last, or rather in my previous statement. Now, in this case, in our subsequent discussion, I'm going to look at the general, or rather the specific characteristics and trends of each of these specific range of groups from 3 to 12. And they're going to assist us appreciate some of their application areas in our day-to-day life. So that is it for now, guys. By God bless you. Catch us in our next video.